All right, scholars, time to continue with our next lesson. Please put your name and number at the top as usual. We're continuing with Module 2 notes. Today we are going to be working on Module 2, Lesson 11. We're going to be doing some more multiplying with decimals. Now, we've been working on this in class. You're going to see a lot more of this in coming class periods. And I'm hoping that it's going to start looking pretty familiar, that it's going to look pretty similar. This lesson is really a lot like what you did in Lesson 2-10. There we are. We're just going to do some more of it, and I'm going to show you a little bit more about why it works, the underlying mechanics of the whole thing. Now, for Lesson 11, we'll put our Roman numeral 11, a 10, plus one more. Okay. But that's probably going to be the end of what looks normal. Again, no vocabulary. We've talked about factors, we've talked about products. I don't want to make you write that down again. So we're going to dive right in to two possible ways to solve. So two ways to solve when multiplying. Now, obviously there are other ways, but these are the two that we're going to focus on today. These are the two that you're going to be seeing in class. And really, I say two, but it's mostly going to be this one. Your friend and mine, the standard algorithm. Most of what we are doing, and even today, most of what I'm going to show you today is really just going to be different ways to pull the standard algorithm apart. So let's say that I give you this problem. 7 and 13/100 times 9. Let's do times 9. Okay. Step 1, stack it. Write it vertically. 7 and 13/100. That's the longer number, so that's what I want to put on top. Times the 9. Now remember, I'm not worried about lining up decimal points when I multiply. I just want to make sure things are lined up on the right-hand side. So, go ahead and put my little bar here. We're going to temporarily forget about this, which again, I'm going to explain over here. 9 times 3 is 27. Carry the 2. 9 times 1 is 9. 10, 11. Okay, that 1's not going to fit, so I have to carry that over here. 9 times 7 is 63, plus 1 is 64. Compared to some of the longer multiplication problems we've been working on, the 3-digit times 4-digit, this is actually fairly quick. The big difference is, of course, the decimal point. 1, 2 decimal places. Count 1. 2 jumps down here. We always start over on this side, and then 1, 2 in this case. There's our decimal. So the answer for this would be 64 and 17/100. Okay. Most of you probably feeling pretty good with that. And again, I know I keep repeating myself, but that's what we're going to be doing in class. However, just a further break from tradition, go ahead and put a little line down the middle. We're going to put number 2, the second way to solve, right next to it. Because again, I want you to see just how similar it is. We're going to call this one the unit method. And if you remember a few lessons back talking about units, changing things into units, then this should look familiar. Now, 7 and 13/100. This is not the only way I can write that. I can write it using units. 713 hundredths. Okay. So 7 wholes, and 13/100 is the same. It is equivalent to 713 hundredths. The difference is I'm just writing this all as one unit, hundredths. Over here, I'm mixing units. I've got a whole number, I've got a decimal part. It's kind of a combination. Here, it's a little more direct. We're just dealing with one thing. Now, like I said, I'm hoping you'll notice just how incredibly similar this is, because ultimately, to do this, I use the standard algorithm. Calling this two different procedures, two different ways to solve, might not be entirely honest. Really, we're doing the same thing, but hopefully you're noticing no decimal point. I multiply exactly the same as I did before. 9 times 7 is 27. Carry up that 2. 9 times 1 is 9. 10, 11. Carry up the 1. 9 times 7 is 63. 64. This is why we can ignore the decimal point temporarily. Again, you're just multiplying. Now, what's different is I am going to label with the same unit I had up above. Hundredths. Hundredths. There we go. Okay. 6,417 hundredths. Now, we're not going to really write it that way. We're not going to leave it that way. Okay. If you remember, when I'm using units this way, whatever that last digit is, 7 in this case, that has to be in the hundredths place. So moving over to the left, that makes this the tenths place, which means there's a decimal point right there. Interesting. We are doing the same thing. We're just moving it over 2 places. Now I'm going to do some examples with you down below. I'm hoping this will be a shorter lesson. A few of you were very frustrated with the length of the last 2. So let's jump ahead. I am mostly going to be doing this because, like you can see here, it's pretty much the same thing. All we're doing is writing the units, and that allows us to get rid of the decimal point while we are multiplying. If you are okay just kind of remembering that you need to count over, you don't even have to do those mental gymnastics. You can just jump right there. Okay, so examples. Let's do 2 examples. I'm going to slide this up. Let's start with 2 and 42 hundredths times 12. Now again, I can do this both ways. This is equal to 242, whatever that last place value is, 242 hundredths. Goes out to the tenths, goes out to the hundredths. Okay. Multiply that times 12. These are exactly the same problem. Different form, I guess, different appearance, but otherwise very similar. Okay. So I'm going to write this one vertically, and I'm going to write this one vertically and point out for the bazillionth time how they're just the same thing. In fact, I'll start on this side. 2 times 2 is 4. 2 times 4 is 8. Now I am going to slow down because I want to make sure we're talking about the focus. This times 2. This times 4. This times 2 again. This is something I kind of developed a little bit later when I was working with students, and it seemed to help. But every once in a while I fall into my old bad habits and forget to do it. So I try to make sure I'm doing that for you. Okay, 1 is in the tens place, which means nothing can be on the side of this line except the spacer 0. Everything else, when I multiply 1 times 2, 1 times 4, 1 times 2, all of that's going to go over here. And since it's 1, that's pretty easy. Okay. Go ahead and add these together now. 4 plus nothing is 4. 8 plus 2 is 10. Carry the 1 up here. 4 plus 4 is 8, plus 1 more is 9. Nothing plus 2 is 2. Okay, so the answer is going to be 2,904 hundredths. I am just using the same unit from above. I'm just going to bring it right down and use that same unit. Now I am going to change that 2,904 hundredths, last digit in the hundredths place, which makes this the tenths, which means a decimal goes right there between the 29. I'm, in fact, going to make that a little more clear. Okay. There's my tenths place, there's my decimal, and that 9 was there a minute ago. Again, I wanted a little more space. I wanted you to be able to see it. Okay, we'll come back to this in a moment. The answer should be 29 4 hundredths. We'll come back to that. Okay, 2 times 2. Focus, Mr. Landre. 2 times 2 is 4. 2 times 4 is 8. 2 times 2 is 4. Okay. Looking very familiar. Spacer 0. 1 times 2 is 2. 1 times 4 is 4. 1 times 2 is 2. Focus, Mr. Landre. 1 times 2. 1 times 4. 1 times 2. Okay. These pencils, you know, I'm starting to think it's me, considering every mechanical pencil I have is starting to misbehave. Starting to think it's me. All right, add these up. 4 plus nothing. 8 plus 2 is 10. Carry the 1. 4 plus 4 is 8. Plus 1 is 9. Nothing plus 2 is 2. 1, 2 decimal places. 1, 2 decimal places. And if I zoom out, it's looking pretty close to what I had over here. Remember, I just 1, 2 jumps because there were 2 decimal places up here. Hundredths, tenths, you're working backwards. You're doing the same thing. Now, I did say these notes would be a little shorter, but I also said we'd do one more example, so I will split the difference. I am going to give you this problem to work out on your own, please. You may choose whichever method you prefer. 371 3/10. This is tenths, but otherwise it's going to work the same way. Times 24. 371 3/10 times 24. Go ahead and work that out. You should have hopefully plenty of space left on your notes, on your paper. And next time I see you in class, we'll take a look at that and see what the answer should be. For now, I wish you luck. Make sure that if you have any questions, you write those down, you jot those down, and we'll cover them in class. Thanks, everybody. Have a good one.